Climate change. This week we're going to look at probably the most controversial issue in environmental science. Interestingly enough, universally scientists accept that climate change is occurring and accept the idea that those changes are being accelerated by human activity. The reason that it's so controversial is how are we going to fix it? Answering that particular question. Those climate change deniers essentially are saying that humans aren't actually causing the problem and that, we don't need to do anything because natural cycles will bring climate back into a stable state at some point in time. Those proponents of climate change argue that we need to, as humans, do something to start reversing the forward movement of increased global temperatures. Otherwise, we're going to have catastrophic events. So the science behind climate change isn't really argued and isn't really debated. It's pretty accepted in the scientific community. The solution is what makes climate change and the issue of climate change so controversial. First of all, climate refers to the atmosphere, how it behaves, and how it is composed. Climate processes involve the movement and storage of energy, including interactions with the land surfaces and with oceans. Rising sea levels that threaten coastal Florida are one example of this interaction. Earth's atmosphere consists of gas molecules, relatively densely packed near the surface and thinning gradually as you go up. In the lowest layers of the atmosphere, air moves ceaselessly, flowing, swirling, and continually redistributing heat and moisture from one part of the globe to another. The daily temperatures, wind, and precipitation that we call weather occur in the layer of the atmosphere called the troposphere. And long-term temperature and precipitation trends we refer to as climate. So weather is our daily temperature, precipitation. Climate refers to long-term averages of precipitation and temperature. The atmosphere that we have now is very different than the atmosphere that existed on this planet when it was formed. Back then it was mostly hydrogen and helium, and now 78% of our air is nitrogen, 21% is oxygen, and the remaining 1% is a mixture of argon, carbon dioxide, and a variety of other types of gases. Water vapor varies from near 0 to 4%, depending on the air temperature and the available moisture. And then minute particles and liquid droplets, collectively called aerosols, are also suspended in the air. When we talk about climate change, we're talking about these long-term changes or rises in temperature that we see occurring over the course of the last several hundred years. We used to refer to climate change as global warming. The problem with global warming, or using that term, is that it's making the assumption that because the planet is warming, all of us are experiencing higher land temperatures, and that's not necessarily the case. So scientists are really trying to move away from using the term global warming to using the term climate change. Climatologist Waller Broecker has said that climate is an angry beast, and we are poking at it with sticks. He meant that we assume our climate is stable, but our thoughtless actions may be stirring it to sudden and dramatic changes. How stable is our climate? That depends upon the time frame in which you consider. Over centuries and millennia, we know that climate shifts somewhat, but usually we expect little change on the scale of a human lifetime. This is no longer a reasonable expectation. You have all seen the effects of climate change in your everyday life. If you live in this particular area, you've seen the increase in flooding, in mudslides, in rain events. We've had 100-year rain events twice in the last 10. We see it with the drought in different areas of the world. We see it with changes in snowfall, behavior, and patterns. If climate does shift, how fast might it change, and what will these changes mean for the environmental systems on which we depend? This week we're going to look at the impact of climate change on humans, and not just humans, but on biodiversity, on ecosystems, and our Earth as a whole. What are humans doing to accelerate this process, and what can we do to try and change this trend in rising global temperatures?